In this new Feature 2024 tutorial video, you will learn how to use faulty automation, specifically creating mappings. There are 5 objectives for this video. The first objective is to map one task with one keyword. The second is to map one task with 2 keywords. The third is to create one mapping for multiple tasks with a wildcard, the countable $sign. And the fourth is to create one mapping for multiple tasks with a custom counter. The fifth objective is to export the mappings as a faulty knowledge database. We will illustrate the mapping process by first creating mappings for the piles and the pile caps respectively. You can go to More Options to locate the faulty simulation app. Expand the Foundations task to review the piles and pile cap tasks. Click on the Piles task and then click on Faulty Automation. The mapping window is opened. We will choose some keywords which will allow us to uniquely identify the required 3D objects for the tasks in question. These keywords originate from the names of the tasks and their parent tasks in the work breakdown structure. If you recall highlighting words in a textbook to jot down important points, a mapping works in a similar way. We can associate the scheduled task name with one or more BIM object attributes by first highlighting a keyword from the task name, and then selecting the relevant 3D object attribute from the generated drop-down list. In this case, the piles keyword itself is sufficient to identify all pile objects, so we can just highlight piles and then choose parameter from the drop-down list. This option allows for any of the BIM data to be used as a classification in the mapping. Choose the category attribute under the classification column. The operator equal to specifies an exact value match, and the value we are looking for will be piles. We can type in the first few letters to locate the word faster. Click on the gray ball to activate the mapping. If the ball turns green, then it means that the objects have been successfully mapped to the task. We will repeat the same process with the pile caps. Click the pile cap task, then click New Mapping. Highlight Pile Cap, then choose parameter from the drop-down list. Next, select Category under Classification and Pile Caps for value. Click on the gray ball to activate the mapping. Most of the time, one keyword is not enough to uniquely identify 3D objects for the tasks. We'll map the floors to explain this. In our scenario, there are 15 floors in this building, so we will have to utilize the level BIM attribute alongside the category attribute to map each floor object to the respective tasks. Select the floor task on the ground floor and click New Mapping. Highlight ground floor and choose parameter from the drop-down list. The reason why we selected parameter instead of level is because the level option only recognizes level BIM attributes from Revit. If the attribute has been added in Fuzor, which will appear under the Object Description Fuzor tab, then it will be omitted. We can then select level for classification and ground floor for value. Next, highlight floor and choose parameter AND from the drop-down list. Select Category for classification and floors for value. Click on the gray ball to activate the mapping. The ground floor has been mapped to the task. The mapping process is the same for the roof floor. Click the floor task under Roof and click New Mapping. Highlight Roof and choose parameter from the drop-down list. Select Level under Classification and Roof for value. Next, highlight Floor and choose parameter AND from the drop-down list. Select Category for classification and Floors for value. Click on the gray ball to activate the mapping. The roof floor has been mapped to the task. To map the rest of the floors from the 2nd floor to the 15th floor, we can imagine that the pattern is the same. This time, instead of creating one mapping for each floor, which can also be done by the object filter, we can use the wildcard the countable $sign for the floor number. Click on the floor task under 2nd floor and click New Mapping. Highlight 2nd floor and choose Parameter from the drop-down list. Select Level for classification. If Identify is selected under the Counter column, then you can only select a particular floor from the Value drop-down menu. Yet if we switch this to Countable, this rule will be moved to the AND view, and it will be able to recognize different floor numbers that follow a specific format instead of a specific floor. For floors 2 to 15, the value in the element properties is a single number. Therefore, we can select the $sign wildcard in the value column for lookup, which represents floor number in this scenario. The result is that the floor number highlighted in this task is recognized, and the corresponding 3D objects are mapped if there is a match between floor number in the task and that of the level beam attribute of the 3D objects. To complete the mapping, we will have to map the floor attribute too. Highlight Floor and choose Parameter from the drop-down list. Select Category for classification and Floors for value. Click on the gray ball to activate the mapping. All floors have been mapped to their respective tasks. Object filters have also been generated for each floor. As an extra note, this $sign wildcard is able to recognize single letters other than numbers, but this is not covered by this tutorial. While the $sign is for values that follow an established format, what if there are exceptions to this? Examples can be the ground floor, which has ground floor as value instead of a number, or the roof floor, which has roof as the value. In this case, we can use a custom counter. To demonstrate this, we can remove the mappings for all floors by clicking on the bin icon next to our 3 recent mappings. Note that there are no objects assigned to the tasks now. Then click the floor task under the 2nd floor and click Create New Mapping. After that, click Custom Counter. This Custom Counter settings window allows us to add, apart from the regular format, values of exception. Click Add to create a new custom counter. Rename this custom counter to Levels. Then click Add Custom Mapping to define a format for mapping the 2nd floor to the 15th floor. Select Level for the first drop-down list and $sign for the 2nd drop-down list. Now to include the ground and roof floors, we can click Add Custom Value twice and type in the values that are shown in the element properties. Click Close when we are done. We can then select Custom Counter after highlighting 2nd floor. Choose Level for classification and Levels for value, which is the name of our newly created custom counter. The final step is to highlight Floor and choose Parameter from the drop-down list. Select Category for classification and Floors for value. Click on the gray ball to activate the mapping. All floors have been mapped to their respective tasks. Object filters have also been generated for each floor. One of the powerful functionalities of 4D automation is its ability to share databases and hence inherit the knowledge and experience from the experts. The name Expert AI for 4D automation is hence derived from this process. The Export button allows us to save all mappings in this interface externally. This will be the 4D knowledge database. When we export this database to another project, we do not have to create all mappings from scratch. We only have to create new mappings for 3D objects that are not mapped to the tasks. As we save more mappings from different projects, the newer version of the database will have more widespread usage. New users will be able to benefit from their predecessors' work. These mappings can be purely done and stored in-house to maintain the confidentiality of the projects. Mappings for scaffolds, structural columns, walls, structural framings, wall sweeps, and windows have been added in the same way as the floors. Here is the result. Faulty automation speeds up the production timeline of faulty construction sequences. With increased ease of faulty sequence production, we hope that detailed construction planning can be applied to reduce construction delays. Thank you for watching.